Welcome back. So we are looking at problem 4, section 3.5. Question is, which function is shown in the following graph? Okay, I have two options. So the only thing to see is what are my x and y asymptotes. Okay, so the first function is 1 over x plus 1, x minus 2. Notice x equals negative 1 and x equals 2 make the function undefined. In fact, as x approaches negative 1 or 2, the denominator will approach 0. So, the value of the function will approach either a positive infinity or a negative infinity, depending right hand limit or left hand limit of either of these two numbers. In other words, negative 1 and 2 will give you vertical asymptotes. Okay, x equals 9. Another matter to check, what happens when x approaches infinity, either positive infinity or negative infinity, okay, of this fraction. Well, this is a rational function, polynomial over polynomial. The degree of the denominator is x squared. So I'll divide the numerator and denominator by x squared. This x squared gets split into x and x. Because I have two factors here, I'm splitting it like that. So 1 over x squared and this over x and x minus 2 over x. Now distribute the division. You get 1 plus 1 over x and 1 minus 2 over x. Numerator is 1 over x squared. Now if I let x approach infinity or negative infinity, numerator goes to 0, denominator gives me 1 plus 0, 1 minus 0, that is 0 over 1 times 1. 0 over 1 is a 0. That means I have y equals 0 as the horizontal asymptote. Alright. The second function is fx equals 1 plus x squared over 1 minus x squared. Factoring it, numerator does not factor. Denominator is a difference of squares that factors as 1 minus x and 1 plus x. Numerator, notice because of the x squared, you are always going to be positive or at worst 0. Adding 1 makes you always positive. So the numerator is always positive, whereas the denominator can be 0 when x is 1 or negative 1. So as x approaches 1 or negative 1, the quotient, the fraction, will approach either a positive infinity or a negative infinity depending on left hand limit, right hand limit, left hand limit, right hand limit of these two numbers. So in other words, you have vertical asymptotes at x equals negative 1 and x equals positive 1. What about horizontal asymptotes? Let x approach plus or minus infinity of fx. Okay, this is a rational function. So you divide by the highest power of the denominator, that is x squared. Divide the numerator by x squared. Divide the denominator by x squared. Distribute the division. You get 1 over x squared plus 1. 1 over x squared minus 1. When I take limit x approaching infinities, I get a 0 plus 1 and a 0 minus 1. 1 over negative 1 is a negative 1. So what does this tell me? This tells me y equals negative 1 is the horizontal asymptote. Okay? So, which of these two have, so y equals 0 is the horizontal asymptote of the first, y equals 1 negative 1 is the horizontal asymptote of the second. So notice this graph has horizontal asymptote at 0, height 0. Likewise, let's look at the vertical asymptotes. This second one has vertical asymptotes at negative 1 and 1, whereas the first one has vertical asymptotes at negative 1 and 2. Negative 1 and 2 are the vertical asymptotes. So it's the A. All right. Both the horizontal asymptote is 0. That turns out to be correct. All right. And vertical asymptotes are negative 1 and 2. That turns out to be correct. For the B1, vertical asymptotes are at negative 1 and 1. And the horizontal asymptote is at negative 1. All right. So it's A, that's the correct answer. So simply looking at the horizontal and vertical asymptotes, you can make this judgment. All right. Until next problem.